Omae wa mou shindeiru.
Actually, saya beritahu yang kita ada satu assignment baru yang diberi nama PBL, Problem Based Learning, yang based on situation yang diberikan dalam assignment ni. So dalam assignment ni terdapat beberapa task yang diperlukan. Antara task yang pertama, kita perlu dividekan dulu team members yang terdiri daripada chairman, team leaders and cameraman and ada audience juga. So before that kita decide dulu untuk kita tahu the position of each members lah. Macam mana?
Okay. Boleh tidak saya share screen menunjukkan yang kita punya task tu. Kena ada seorang chairman, so kita kena divide lah, seorang chairman, seorang group leader, seorang cameraman, okay, lepas tu yang lain tu akan jadi participant lah. So kita divide tu task tu. Kita start dengan chairman lah. Siapa jadi chairman?
Saya nak bagi cadangan.
Okey.
Siapa cadangan tu Syed?
Nak cadang Aizad.
Aizad.
Saya cadang Amirul.
Saya menyokong Aizad.
Saya mencadangkan cadangan tutup.
Oh. Okey, cadangan tutup so dua orang antara saya dengan Aizad lah.
Tutup dua orang.
Okey. Saya pilih Aizad sebagai chairman juga lah.
Okay, boleh. So nak
Aizad
memudahkan
chairman
kita. Okay, boleh.
Okay, so Aizad chairman okay?
Okay.
Mantap.
Okay,
Setuju. Okay, next kita team leader pula.
Team leader.
Saya cadang Amirul.
Okay, saya cadang diri saya sendiri juga.
Itu cadangan diterima.
Oh, tak boleh
Cadangan yang tu diterima.
Setuju.
Oh, saya main je tadi betul boleh
Kami menjadi volunteer, kami setuju.
Oh, okey. Baik.
Hafiz kata asalkan bukan
kami
Akram.
setuju.
Oh, asalkan buat okey, boleh. Saya kalau buat gini okey dah, sebab takkan di SRCD pun nak jadi team leader kan. Okey dah, boleh.
Lebih lah Akram.
Tak apa.
Okey. Lepas tu kita cari group leader pula. Saya group leader pula. Cameraman pula. Siapa yang cameraman?
Okay. So cameraman ni saya rasa Syazwan lah, sebab dia berpengalaman dalam bidang
Yang paling sesuatu tu saya lah.
Yalah, sebab kat sini ada dua orang yang power buat video.
Saya pernah nampak Syazwan punya video.
Kat sini kan dia ada dua orang power tau. Satu buat shooting ni yang power Hafiz. Buat edit ni buat yang power Syazwan. So kita lebih kepada edit
tak ada, saya guna
Lebih kepada edit
untuk ambil Syazwan ni.
Okey. So Syazwan okey tak?
Boleh.
Okey, baik Syazwan, terbaik.
Okey Syazwan.
So dari 3, So lagi 4 orang tu akan jadi team members lah, okay kan? Participant.
Okey, boleh.
Okay, participant so participant.
Boleh.
So kita try tengok soalan lah. Kita tengok soalan apa yang dia nak ni. Pelik-pelik soalan ni. Soalan dia kata orang ni ada right hand injury. Lepas tu bawa pergi ke HKL. Lepas tu dia kena melalui satu SOP untuk diagnose injury condition tu. Tapi melalui terapis dengan physician feedback ni, patient tu perlu melalui several treatment procedure. Maksudnya dia tak perlu operate lah kan. Kalau kat sini tak perlu operate. Tapi dia memerlukan macam training lah, fisioterapi lah. So kat sini dia kata
Master straight.
maksudnya?
Master straight tu apa?
Master straight ni maksudnya macam nak cakap
Master straight.
Macam nak cakap Aizad, master straight ni?
Dia ada
Dia sama dengan masa injury.
Masa injury lah, maksudnya mungkin ada koyak ke apa semua tu lah.
Dia not function well. Function.
Keradangan otot.
Oh, keradangan otot. Okey. Otot keradangan.
Otot.
Oh. So kita kat sini kita kena buat apa ni? Kita kena cari clue, problem statement based on clue bawah ni. Kita kena cadangkan lah. Mungkin cadangkan dari segi terapi apa yang perlu. In term of dia punya medical instrumentation system, dia punya power supply, apa lagi ni? DAQ pun kena juga. Lepas tu features dengan sistem fault condition. Okay. Maksudnya dia kata kita kena cadangkan based on kriteria ni lah kan? Betul tak? Apa yang cakap ni?
Betul. Ada 5 kriteria
5 kriteria tu ada kata kita kena cadangkan benda tu based on 5 clue ni. Maksudnya 5 kriteria lah kan? Maksudnya clue je kan? Lepas tu dia kata kena buat apa ni? Lepas tu kena present PBL lah. Lepas tu buat report. Okay. So maksudnya kat sini 5 clue ni kita kena bahagi, maksudnya kena bahagi sama rata dalam participant tu lah kan? Betul tak?
Betul.
So macam mana kita nak bahagi macam mana ni? Participant nak bahagi macam mana ni? Antara participant ni.
Okay.
Untuk first task saya rasa saya boleh buat. Untuk first task.
Syed saya nak buat first task lah. Okay. Saya buat first task
Saya nombor 3.
Hafiz nombor 3
Hafiz nombor 3.
So Hafiz ambil DAQ lah kan? Hafiz ambil DAQ buat
Saya nombor 2. Power supply block diagram.
Okay. Akram nombor 2. Lepas tu?
Akram nombor 2.
Aiman nombor 4.
Okay.
Nombor 5 pun boleh lah. 1 dengan 5.
Okay. Semua setuju lah macam ni? Semua setuju ke? Participant semua?
Setuju. Boleh.
So, maksudnya participant okay.
Boleh je.
So apa yang kita kena buat sekarang ni, saya rasa ni lah, maksudnya masing-masing dah ada task masing-masing. So mungkin kita boleh start ambil masa masing-masing sekarang ni, ambil masa masing-masing untuk kita cari poin-poin tu, mungkin kita boleh discuss sama-sama. Maksudnya poin tu okey ke tak, so kita sama-sama decide apa yang kita nak dapatkan. Okey tak?
Boleh.
Okey, boleh. Untuk saya punya soalan question nombor 2. Okay. So I will show my ni dapat. So basically apa soalan saya ialah power supply block diagram and description. So untuk so power supply ni basically apa yang saya dapat, apa itu power supply. So kat sini regulated power supply. Sekejap saya share apa tu regulated power supply. Power supply ni actually convert unregulated AC into a constant DC. Lepas tu function dia supply a stable voltage. So kalau korang nak tahu ni actually regulated power supply, bentuk dia macam ni. Ni apa yang saya dapat. And untuk basic block diagram saya search banyak dalam ni. Tapi yang rasa okey tak kalau mana yang tadi saya ni. So basically apa yang untuk power supply ni dia ada 4, dia ada 5. So first kali transformer. So and then dia akan masuk kepada rectifier. Dia masuk filter, regulator, and so I think yang ini sesuai. So korang rasa okey tak apa yang saya dapat?
Rectifier.
Okay.
Okay juga, detail juga dia punya ni. Ada label semua.
Maksudnya dia tunjukkan. Maksudnya kalau masuk filter tu apa jadi kan?
Sebab nanti mungkin saya akan terangkan lebih mendalam lah. So sekarang ni saya cari dulu basic block diagram dia. So saya akan cari apa itu transformer, apa function transformer, dan juga and then apa function rectifier, filter, regulator and load, and then apa perubahan. So kat sini apa yang saya mention ni, dia ada perubahan daripada transformer, and then dia akan ada sini, and then masuk filter, dia akan filter kan, and then the last dia punya supply nya akan stable lah. So ada apa-apa tak komen untuk yang ni?
Rasa okey ni sebab tengok macam jelas dia tunjukkan setiap laluan tu apa bentuk signal dia. Okey ni.
So nanti terang je lah blok-blok tu fungsi dia apa kan.
Betul. Yang ni mungkin, yang ni rasanya boleh ni maksudnya letak dalam report kan sebagai contoh. Maksudnya starting ke apa. Okey, baik. Mantap.
Okay guys, ni ada video sikit kalau nak share.
Oh bagus Syed. Ada video senang sikit nak faham. Oh okey, nampak. Oh ni hand grip
So yang ni kita tengok dia tak ada tunjuk circuit diagram ke apa, tapi just to give us the idea of how this thing works. So kita tengoklah video ni, so senang untuk dapatkan gambaran pasal benda yang kita nak design ni kan.
Okey, boleh.
So dalam video ni dia macam deconstruct, dia buka balik hand grip ni. So video ni panjang, so I just skim through. So ni lah hand grip yang kita nak design. So dia ada yang untuk adjust, depends on the size of your hand. Dia ada adjuster yang bulat tu, situ. So dia ada button sampai dia on. Dia pakai battery. So nanti kita boleh discuss whether nak pakai battery macam tu atau rechargeable battery ke untuk power. Okay, masa dia start, dia mula-mula on. Okay, first input is kita nak dia akan input umur berapa, age. Sebab different age dia punya strength reading dia berbeza. Okay, ni untuk umur berapa semua. Sebab dia berbeza, lelaki perempuan berbeza, umur beza dan juga dominant arm ataupun tak. Okay, dan kita boleh pilih unit whether in pounds or kilogram. Lepas tu dia buat, nampak? Dia dapat 131 pounds.
Video ni untuk penerangan yang mana?
Video ni saja just for, sebelum ni aku macam tak clear hand grip ni macam mana rupa dia. So just nak share video macam mana dia macam mana dia berfungsi lah. 134 pound dia boleh convert ke kilo. So dia punya grip strength dia 61 kilo, which is excellent untuk lelaki umur dia 54.
Dia adalah parameter lah. Maksudnya
dia ada parameter dia.
Okay.
Okay, so ada lagi lah dia buka dalam macam mana apa semua.
Oh, dia buka dalam terus
Dia channel ni memang dia akan ambil semua barang elektronik, lepas tu dia akan buka dan dia tengok dalam tu macam mana.
Macam ni boleh nampak dia punya circuit diagram apa kan.
Macam ni senang sikit kita nak imagine macam mana benda tu. Kat situ ada strain gauge dengan dynamometer tu kat dalam tu. Okay, nanti I will share this video link to the WhatsApp group lah untuk you guys tengok, bagi tengok full video ni 10 minit.
Okay, boleh.
Lepas tu ada lagi yang dah jumpa. Ni pun sama lah, link ni dia cakap macam mana kenapa hand grip test ni penting untuk tengok muscle strength. Okay, yang ni I tengok macam boleh guna untuk circuit diagram kalau kita nak pilih something like this. Tapi kena buat research lagi lah. Kalau untuk block diagram maybe boleh ambil yang ni ataupun yang ni. But this one nampak macam sesuai juga. Dia ada dua sensor actually, daripada satu dynamometer, lagi satu daripada EMG. Dia akan letak dekat kita punya muscle, and ada pre-amplified electrode sebab the electrical signal yang daripada muscle kita sangat-sangat kecil. So kita kena ada electrode yang boleh amplify the signal, and then it will be sent for processing. So so kalau kita nak data yang kita dapat tu very accurate, so kita boleh letak dua sensor macam ni lah. Ada dynamometer ada, lepas tu ada EMG sekali. Okay, untuk the first one is medical instrumentation system for the treatment with block diagram and possible circuit diagram. Rasanya dah jumpa banyak information, cuma belum compile dan masukkan dalam report lagi.
Okay. Nice. Nice juga idea tu, Syed. Maksudnya boleh nampak lah, senang sikit nak tahu macam mana function tu kan. Dia punya video senang sikit nak faham tadi macam tadi kan. Tekan tu tengok dah tahu dah macam mana, berapa semua, and then berapa indikator nak menentukan dia okey ke tak kan. Okey, rasanya yang tadi tu okey tu.
And then sebelum ni pun kita tak pernah tengok dalam dia tu. Tadi video tadi je bila dia buka tu baru kita tahulah macam mana kan.
Yelah. Sebab kadang-kadang daripada circuit diagram dengan block diagram susah nak imagine macam mana benda tu in real life.
Betul lah. Nampak macam sebenarnya nampak kat circuit diagram ke block diagram macam payah je kan. Tengok
Yelah.
tadi macam macam tu dia connection dia. Nampak direct terus lah.
Sekarang nombor 3 pula okey, apa yang saya jumpa. Okey, ni saya jumpa dekat Wikipedia. Data acquisition. Okey, ni dia punya definition dia. Process of sampling signal. Laki kat sini dia set bagi dia punya block diagram. So ambil yang ni je lah. Boleh kan?
Boleh, ni terus turang lah. Apa step by step dia?
So sini just dia bagi tahu untuk yang definition je. Dia pun definition, cuma dia bagi kat sini part of the ecosystem. Gambar ni kita boleh ambil kan? Boleh masukkan sekali.
Ni dia beritahu ni DAQ punya ni function
dia nak lebih fahamkan lagi dia punya apa part-part dia, sensor tu apa, device ni apa,
integration dia. Ni rasa boleh ni. Dia nampak macam sensor masuk DAQ masuk komputer. Okay.
Lepas tu nanti terang dia punya signal conditioning, ADC dia. Dekat sini pun dia ada bagi komputer software apa yang jadi kat dalam tu, driver dengan application dia. Ada video, cuma tak tahu kita boleh ni ke tak. Video tentang data acquisition. Tak tunjuk yang ni. Di sini ada transducer.
Okay.
So dia beritahu macam ni lah. So masa waktu terang nanti mungkin boleh terang lah tu sambil tunjuk yang ni.
Boleh juga ni Hafiz. Maksudnya sambil terang nanti kan. Boleh guna video ni. Nak tahu lebih senang kan. Maksudnya terus nampak apa function dia.
Sebab kat ni ada grafik kan, senang dia nak faham.
Betul.
Itu je lah untuk data equation nombor 3.
Yes Hafiz. Bagus lah. Sebab tadi nampak yang tadi kan. Yang tu bagus lah. Yang sensor masuk tu tadi. So, sebenarnya macam tak tahu sangat DAQ tu apa kan. Maksudnya dia sensor tu masuk kat DAQ tu masuk komputer gitu lah. Betul. Nice. Boleh masuk tu.
So, soalan seterusnya dia minta external features including automation control of feedback system.
Lawa. Nak beli jin ke tu?
Ini first bukan. Ini first saya fahamkan dulu feedback system apa dia punya teori dia tu. And then saya akan baca ni. So ini dia macam dia dah terangkan dah.
Dia tak apa Mat, tanya feedback system.
Feedback system ni macam kalau yang selalunya kalau input and then kita akan masuk dalam proses and then jadi output. Okay, selalunya input and then process and then output. But for this feedback system, dia output yang terakhir tu dia akan jadi feedback kepada next input. Jadi bila kita tengok dia punya grid strength tu, kan kita nak tengok dia punya pressure, kita boleh monitor lah kalau dia punya grid tu semakin lama semakin kuat ataupun semakin lemah dalam masa tu. Based on the data yang kita akan dapat nanti. Asalnya itu je kot. For control system, kita tahu kita guna robot lah kan. Macam ni bukan robot, kita guna sistem dalam tu. Kita panggil automation system lah.
Dynamometer.
Ini untuk external feature ke Mat?
Nombor 4, external feature.
Maksudnya yang
Dia sama ada automation system or feedback. Saya akan terang feedback.
So untuk automation control tak ya kan?
Yang tu sekarang ni memang tak.
Okay. Jadi aku boleh
definition yang betul.
Kita nak proceed dengan nombor 5
Alright, boleh.
Okay, untuk nombor 5 dia kata system fault condition in which the suggested system fail to supply sufficient power source to the system in order to operate and function accordingly and provide possible solution. So maksudnya apa solution kita in the event of, sebab any medical equipment yang guna, if let's say equipment tu guna direct supply electricity, if let's say masa tengah guna blackout or apa-apa ataupun oversupply ke apa, what is the solution ataupun backup plan yang kita boleh ada. So in this case rasanya if we are to use a direct supply, so masalah dia akan jadi bila blackout lah, ataupun apa-apa masalah yang menyebabkan tak cukup power supply kepada kita punya hand grip testing system ni. So yang based on the research that I have done, so first of all I propose that kita guna rechargeable battery untuk kita punya hand grip strength test system for obvious reasons. Dia boleh jadi backup kepada direct supply in case of blackout or anything, dan juga untuk pastikan tak ada the electrical connection is in good condition, kita boleh buat EST, which is electrical safety test, macam Fluke products. Dia ada banyak products yang kita boleh buat EST, dan juga kita boleh guna EST on our system to ensure that the safety standards are met dan juga tak ada masalah yang mungkin akan berbangkit bila patient pakai. So itulah ada dua apa yang dicakap tadi? Suggestion yang saya rasa kita boleh buat, which is firstly we use rechargeable batteries, and secondly is the electrical safety test EST. So agak-agak dua tu cukup ke tak untuk nombor 5? Dua suggestion.
So untuk ni untuk check sama
Okey je.
Okey dah tu.
sufficient power source. Okay. Especially lah macam especially medik ni memang kena buat EST kan. Check dia faulty ke, ada leakage ke apa kan.
Yes.
Okay ni sebenarnya yang paling main tu sebenarnya EST tu.
Betul.
Mana-mana
Betul,
pun kalau
saya
barang
macam
medical,
tertarik juga lah.
mana-mana pergi pun kalau barang medical memang kita kena buat EST kan, macam nak check leakage dia apa semua.
Dia mesti pass semua safety test yang dalam setiap standard.
Mungkin boleh letak ni. Syed boleh letak ni Syed. Sebagai contoh yang tadi tu kan, yang gambar tadi tu yang berapa parameter dia kan. Boleh letak ni contoh. Okey, ni contoh kalau kena pass, maksudnya kena below daripada range ni kan. Ni boleh letak contoh dalam report. Mungkin letak sini. Ni contoh kalau nak test.
So rasanya dah cover kot yang tu untuk number 5. So kita boleh proceed dengan ada lagi ke lepas ni?
Nanti kalau macam kalau jumpa apa-apa je kita boleh just tengok lah.
Kita boleh share ni.
Saya
ada jumpa sikit tentang data aggregation yang block diagram tadi. Ini dia punya penerangan lah setiap block diagram ni, setiap block ni, signal conditioning, ADC dengan komputer. Physical that can be used. Okay, sini untuk diterangkan untuk physical system punya block, physical condition that can be used as input of data aggregation, which can represent in digital form, which is like temperature. So kita we use the temperature for the period. There are untuk block lain, transducer sensor, dia ada signal conditioning, AND. Last kali tu komputer nanti boleh cari lagi, tak jumpa lagi. So boleh kot tambah yang ni kan.
letak je final report ni sebab yang ni kan dia kena mena dengan itulah yang DAQ tu kan. Boleh letak ni. Maksudnya boleh letak tunjukkan lah dia punya step-step tu. Especially dia, cuba tengok metodologi ni.
Metodologi.
Dia belakang lagi. Dia belakang ke depan, dia belakang sikit.
Next. Okay ni.
Ni okey ni. Ini kan dia bagi tahu method untuk kita guna DAQ tu. Tengok dia kata kan sensor tu convert kepada electric signal. Lepas tu nanti condenser tu kalau dia akan detect lah. Lepas tu dia akan convert dalam bentuk output ke ni, analog punya output ke apa. Lepas tu dia sistem tu akan dikira sebagai DAQ lah ni. Okey ni Hafiz, rasa ni 4K juga ni. Kiranya for kita
Yang
punya
ni
extra info.
macam yang kita buat eksperimen tu ke pakai light view tu?
Betul. Maksudnya kalau guna light view memang kita boleh guna DAQ ni.
Sama.
Sama.
Ada juga jumpa video yang ni. Pasal light view tutorial data equation. Video ni dia terang pasal tutorial lah, tutor untuk light view, cara nak gunakan data equation. So ni dia terangkan proses, definition and block diagram. Dia bagi tahu pakai interface circuit. Dia tunjuk lah cara adjust dia punya. Basically video ni untuk tutorial lah, cara nak pakai data equation. Nanti saya share link
Okay.
Alright, itu je.
Jadi rasanya kita semua dah ada clear idea dengan points yang kita boleh masukkan lah dalam setiap yang required. Nanti link video tu semua nanti kita letak dalam WhatsApp group lah untuk semua tengok, bagi fahamkan semua.
Yalah, sebab nak tahu juga kan apa function semua tu, letak dalam video tu nanti. Lepas tu nanti time PBL tu pun boleh tunjuk juga. Lepas tu even macam kadang-kadang dalam video sendiri pun kita boleh guna video tu untuk maksudnya letak mungkin untuk lebih faham ke ataupun tak report pun boleh, mana-mana boleh. Video tu pun kita boleh jadikan sebagai reference nanti. Maksudnya kita punya report kan kena letak reference kan. Kita boleh letak video tu.
Kita punya reference dalam format apa untuk ni report ni?
Sekejap tengok. Dia minta format apa
IEEE ke? APA ke?
Kat sini tak ada beritahu dia minta apa, tapi kita guna standard lah, APA 6.
Okay. Oh, ada 3 markah untuk reference.
Ada.
So, Chairman macam mana? Ada komen ke?
Tak ada lah. Tak ada. Tapi just nak to be clear kan. Actually yang tentang hand grip ni, apa yang dia lebih tekankan, apa yang hand grip ni adalah untuk diagnose. Ini untuk information lah. Core PR and periodicity. Dia seperti yang saya cakap tadi tu. Dia untuk measure static force that hand can squish around the manometer yang tadi saya tunjukkan macam sebiji juga macam dalam video tu. Dia juga boleh indicate overall muscle, tapi yang best dia sebab dia beza tau, dia ikut age, dia punya gender, strong factor dia juga. Lagi satu yang main point juga yang kita boleh jadikan ni adalah dia punya position. Kalau dia berdiri berbeza dia punya value tu, ataupun duduk. Saya share screen nanti. Ada punya data yang diorang buat cara duduk, contoh degree, elbow. Macam hand tu juga pun main peranan. Kalau dominan dengan tak dominan, position dia macam mana. Kalau dalam elbow tu 90 degree atau forearm natural. So kalau tengok ada punya cara kedudukan dia, sitting position ataupun standing upright. Itu je, just untuk for your information lah. Lagi satu tentang failure tadi. Failure tadi tu pun boleh macam kita add on lah. Contoh dari segi kan selalu ada certain transformer right, ataupun kapasitor dia selalu problem kan. Macam ni kita nak overcome benda tu. So might be boleh di add on right. Nanti I share lah dia punya link. That's all. Ada lagi ke?
Oh, one more just for information juga, for just for sharing Sebenarnya hand grip strength test ni walaupun nampak simple, tapi dia boleh jadi indikator kepada macam-macam health condition. Okay, just to list a few. Firstly, kita boleh, if you have the right amount of data daripada the hand grip strength test, kita boleh not exactly diagnose, tapi dia boleh menunjukkan yang ada possibility osteoporosis disease, cardiovascular disease and cancer in men, ataupun disability later in life. So kita boleh tengok kalau if at a young age, let's say dia ada hand grip yang lemah ataupun irregular data, so benda tu sebenarnya boleh jadi satu prediction that dia ada possibility to develop certain serious disease. So sebenarnya hand grip strength test ni walaupun nampak macam sangat simple, tapi sebenarnya dia boleh jadi satu indicator yang penting for our health lah.
Okay, Syed, kau kan athlete kan? Before this, dia ada ni ke kalau macam kita nak player untuk tenis kan? Dia ada take accuracy untuk hand grip? Ada ke? Ke tak ada? Dia test tu.
Ada rasa aku pernah buat dulu. Kalau tak silap dalam aku dapat dalam 79 kilo kot.
Dia lagi kuat, lagi bagus ke macam mana?
Dia kalau lelaki 64 kilo ke atas dia excellent. Kalau yang dia kalau bawah 40 kilo yang tu very poor. Yang tu dia selalunya orang yang ada penyakit lah.
Macam ada problem lah. Strength je tak cukup lah.
Strength tak cukup. Maybe kadang-kadang maybe dia ada masalah tulang ataupun masalah masa dia sendiri. So dia boleh, so doktor boleh gunakan data tu untuk further check lah dia sihat ke tak ataupun ada penyakit yang lain.
Macam itu dia tak boleh main lah betul.
Tak boleh.
Okay, nice information. Thank you, Syed. Okay, ada apa-apa lagi nak tambah untuk kita punya ni? Untuk kita make over kita punya report after direct.
So overall okay ni setakat ni.
Okay.
Cuma make sure nanti itulah masing-masing punya part tu maksudnya dah dapat idea tu semua, concludekan dalam bentuk satu report masing-masing tu lah. Maksudnya finding tu susun semua dalam report, so kita akan dapat finding yang lengkap lah maksudnya tersusun itu. Dia ada link antara satu sama lain.
Team leader ada ni kan sebelum kita nak habiskan.
Okay, rasanya mungkin team leader ada sedikit team leader mungkin chairman ada sedikit motivation ke untuk nanti kita kan nak kena present tu kan minggu depan kan kita nak present PBL.
Alright, untuk yang minggu depan punya ni make sure overall the data and then also dia punya isi dari segi apa yang untuk dicakap nanti hopefully prepare well.
Untuk present hari yang present tu kita terus present yang kita dah compile dalam report kan?
Betul lah. Maksudnya nanti minggu depan tu kan kita nak present tu nanti. Tak sure hari apa lah. Kita nak present tu nanti kita susun yang untuk report kita just present kita punya idea based on report je.
Alright. Okay.
Untuk cameraman buat apa
Cameraman basically macam ni kan, macam kita discuss semua. Cameraman kena make sure yang apa yang kita discuss ni semua catat semua benda tu. Cameraman ni basically kalau dalam organisasi orang panggil secretary lah kan. Cuma kalau kita buat PBL dekat kelas tu mungkin PBL cameraman kena record semua idea ke apa. Kalau macam ni cameraman kena tunjukkan progress, basically video lah, progress semua. Nanti time PBL tu paling penting lah, kena record the whole session daripada awal sampai habis, especially including Q&A. Macam tu lah overall cameraman. Basically cameraman akan reflect the whole team punya work. Cameraman akan reflect.
Alright.
Make sure prepare tau minggu depan ni.
Alright.
Kita jumpa nanti lah minggu depan.
Alright. Assalamualaikum warahmatullahi wabarakatuh and good afternoon guys. Before we start, I would like to introduce myself first and also my team member. My name is Muhamad Aizad bin Kamal. And from the team, which is consists of 6 of them, we start with the team leader first, which is Muhammad Amirulizzat. For the cameraman is Muhammad Syazwan Baharudin. For the participant, we have 4, which is consists Syed Ariff, Hafiz, Muhammad Akram Rosli, and lastly Muhammad Aiman Hazim. Now, we feel more grounded and present. Let we dive into the problem statement that have been given. So before that, I'm as a chairman. This is a problem statement that we give to solve this, which is from this a patient with right hand injury has been brought or have been warded at the Hospital Kuala Lumpur, the patient required to undergo standard operation or SOP to diagnose the injury of the condition. Based on traffic and physician, the patient has to undergo several treatment procedure instead of the suggest for surgical operation. Therefore, an accurate and right way of hand grip strength system would help the physiotherapist to establish realistic objectives of treatment. So, the main point is how we want to help the patient with the right hand injury by just doing physiotherapy instead of the surgical. Before I pass to the team leader, I have one quote to the team. The way to achieve your own success is to willing to help somebody else get it first. Now, you may proceed, team leader. Thank you.
Okay, thank you, Chairman, for the explanation regarding problem statement. So basically, what the Chairman want regarding the outcome is basically we want to produce something or generate some ideas regarding something that can help the patient in terms of his or her right hand injury, especially the muscle strain, in terms of treatment instead of doing surgery operation. Okay. So before I start doing discussion with the participant, so I would like to give the clue to all the participants regarding what idea should we produce in this discussion. Okay, the first one, the clue is that we have to produce something that is related to medical instrumentation system for the treatment with if possibility if produced in terms of block diagram and also the possible circuit diagram in terms of the treatment itself. The second clue is that the power supply block diagram and its description and also the specification as well as the performance of the power supply so that the data generated from the patient can be continuously recorded and for continuously monitoring. Okay, the third clue for the participant is that the data acquisition block diagram and its description as well as its functionality to acquire data at a high speed, especially in terms of sensitivity, accuracy, stability, must be taken as a consideration in order to produce something related to the AQ system. Okay, the fourth one, the clue is that external feature including automation control as well as feedback system. Okay, the last clue is that system fault condition, which means that we have to suggest if let's say that the system have a fail on its power source. So how we want to provide the possible solution. So by that, I would like to ask the first question first. Can anyone give suggestion regarding the medical instrumentation for the treatment of the block diagram or possible circuit diagram?
Okay, thank you to our team leader, the respected chairman, and my fellow team members. I would like to propose a few systems that we could use for our hand grip dynamometer. But before going into detail, let's go to an overview of what the device is. So the purpose of using a hand dynamometer, it is to measure what is the maximum strength of the hand and the forearm muscles. So this device, this hand dynamometer, it is adjustable in terms of hand size, and it must be calibrated regularly for consistent results. So, and also research have shown that grip strength, it is related to, and also it could be predictive of other health conditions, such as grip strength can be positively related to osteoporosis or bone mineral density, increased mortality from cardiovascular disease, and from cancer in men, frailty and disability later in life. So actually, not only it is an indicator of the muscle and overall health, but it could also be a predictive data for doctors to predict possible injuries for the patient. So before designing this system, we have to know what the basic parameters are that differs from person to person. So firstly, of course, the gender difference. So male scores are usually different from female scores, and also what is the age of the patient, what is the dominant arm of the patient, because non-dominant arms, let's say if someone is right-handed, then usually their left hand or their non-dominant arm scores 10% less in terms of the readings of this hand grip test. Also, the factors that come into play is their height and also their body weight. So maybe someone with an overweight body mass index BMI would have a less score than a healthy person. So now I would like to go into the block diagram and possible circuit diagram.
Can I interrupt? I just want to ask regarding maybe you can show to every one of us the screen or maybe the point in term, or maybe you can share your screen.
Oh, okay, sorry.
All right. So that we can have a clear view regarding what actually you want to discuss, right? Yes.
Yes.
Okay, so this is just a short video that I would like to present just so that we have an idea of how the thing looks like in real life and how it works. So this is the unboxing of the dynamometer and grip. So I'm just going to skim through because it's a 10 minutes video. So this is the adjustable hand grip depending on the size of your hand. And you can see there are a few buttons here. When you switch it on, the first data that you are required to input is what is your age. Okay, there it is. So this man that is using, his age is 54. So he would set the age first, and then he's going to start doing the test. Okay, and also it is you can change the units whether in kilogram or pound. So now he's doing the test and he's scoring at 131 pounds, which is for his age group is excellent. It's a very good reading. So okay, so basically that's it for how this device works. So now we go to the diagrams. So these are the parameters that I discussed earlier. And if you are wondering what are the expected results based on the age and also the genders, so these are the readings for males. Any readings above 141 pounds or 64 kilograms is considered excellent, while for females it is significantly lower because if they score higher than 84 pounds or 38 kilos, it is considered excellent already. While on the other end, males that scores less than 88 pounds and 40 kilos, it is considered very poor. And also 44 pounds and 20 kilos for females. These are the muscles that are involved when you perform the hand grip test. So this is the wrist extensors and also the wrist flexors. Okay, so here is the block diagram that I propose that we use. So we are collecting data firstly. One thing to note here, the video that I showed, it only uses a dynamometer as a sensor. But for our system, I propose that we use two types of sensors, which is firstly the dynamometer, and secondly, we use an EMG system because the EMG it traces and detects very small electrical activity from the muscles, which will be amplified, the signals, using pre-amplified electrodes, since the signals is very minute, very small in the readings. So to ensure the accuracy of the data and the reliability of our data, I propose that we use two type of sensors, which is the dynamometer and also the EMG, which will be sent for data acquisition and data processing. And then you can see here the flow of the block diagram. And also the EMG could detect if there are any abnormal readings from the forearm. So it could also be used to detect if there is some sort of error in the readings or if the muscle is not transmitting proper values of electrical signal. So that is for the block diagram. Is everyone clear about the block diagram?
Yes.
Yes.
Okay.
Yes,
That's
I
good.
clear about that.
Yes, we will proceed next. This is the circuit diagram. So it's actually pretty simple, if as you can see here. Yeah, I think for my part, the first one, I think that's it. If you have any questions, you can ask. If there are no questions about the first one, maybe we can proceed to the second one. Team leader.
Okay, thank you, Syed, for the wonderful explanation. Basically, what you are suggesting in terms of block diagram and in terms of circuit diagram is for the hand grip thermometer, right? Okay, I think we are well explained regarding that, so we can know an overview regarding that matter, especially when you are showing the video as well as the block diagram itself, so we can know what we want to use in terms of sensor, especially the processing part. I think that is a good idea regarding that. Okay, we can move to the second clue, which is the power supply block diagram and its description in terms of power supply, so that we can generate from patient can be continuously recorded and for continuous monitoring. So can I know, anyone can give an idea regarding what power supply that can be used for our problem?
Okay. Alright. So I have a suggestion for that power supply block diagram. Okay. So let me to everyone about what is the power supply. So I will share this one, my slide. Okay. So this is the diagram about the power supply. So firstly, in order to perform continuous monitoring, a power supply is needed. It's very important for us. If the power supply a failure or something have happened, so it will have a lot of things that will come. So if have medical imaging, it will cause the medical imaging procedure will have some data can be lost or some data can be here. So the power supply is very important for the equipment. So I will show you about the block diagram. So firstly, block diagram for the regulated power supply. So it have five thing, the important thing for the power supply. For the first one is a transformer, and the second one is a right. The third one is a smoothing. It's called a filter, and then it have a regulator. Okay, let me explain more about a transformer. Okay. You can see this one is a waveform. It have from AC supply. So this is this basic diagram. We put the to work. Okay, so a transformer basically is the electrical device which have electromagnetic induction that transfer electrical energy from one electric to so transformer have a lot. So in the example for the transformer is like a step up and step down transformer. We have a power transformer, this version. So in this one, we use the transformer of step up and step down. So next I will explain more about the rectifier. Okay, so this the rectifier. So rectifier is basically convert the AC current to the direct current which is DC. So you have the waveform if when the waveform is like this, and this one will convert this, and that's one. The third one is the filter. As you can see at this one, when it have a waveform, and then the output filter and be. So the function of our supply filter is move out the ripple content that in the pulse and of the DC obtained from the rectifier. And then you have two type general, which have a capacitor input and choke input. Okay, and the last one that I want, the last one is about the regulator. Regulator basically designed to automatically maintain the constant voltage level. So when you look at the block diagram, the filter one is the poor DC output. Okay, so and the last one is the load. The load is come from the power supply to operate for the thing. So I will suggest the performance. So introduction about the SMPS. This one is the SMPS of the figure of SMPS is called switch mode power supply.
Okay, so basically what you are suggesting just now is regarding the first one is the voltage regulator supply, right? So by hand
Okay.
you also mentioned about SMPS, right? So in terms of you are suggesting you want to use SMPS for the system, right? So can you basically
Okay.
describe more in terms of SMPS maybe in terms of application or block diagram that maybe you can show so that we can more like knowledge regarding SMPS.
Alright, so as I mentioned before, we will use the switch mode power supply. I will show to everyone the block diagram for the SMPS. Okay, so this is the SMPS introduction about SMPS. As we can know, this one we also like the power supply diagram before. So we have a transformer. We also have a rectifier, regulator, and the filter. So I will introduce more about SMPS. SMPS is based supply they also called high frequency AC/DC converter, which operate the high frequency waveband. Okay, so in SMPS basically it have 5 things in the circuit. We have an inductor or transformer. We have a power transistor or power MOSFET. We have a diode. We have electrolytic capacitor and pulse trigger. To complete the circuit of SMPS, it shall be include 3 types. We have AC filter, primary DC, and IC regulator. So in a healthcare technology, most biomedical equipment using the SMPS. So this one, I will show this one. SMPS is more efficient than from LPS. Do you know the LPS?
I think LPS is linear power supply, right?
So LSPS basically is limited power source. Is designed for safety reasons to confirm the measurement. So to LPS and SMPS. Why we use the SMPS is because with the efficiency of the output it will more high. So as you can see, specification is 70%. This one LPS specification is have 30% only. Okay, and the SMPS specification better than LPS because we have a 2 watt and just we have a 40 watt and SMPS also have. So this we ensure the SMPS is more better than LPS specification. So I want to show you about more about SMPS. I will show in the YouTube. Everyone will look this one. This is a simple switching mode power supply. So you can see this one. I will play this one.
Today
right?
is an interesting topic about the assembly of simple
So
compact
this equipment
Here you can see the finished power supply. I did it for a specific purpose. It is
supply.
planned to collect small switching power supply with an output voltage
So
of
we
about
have
40 volts and a current of
fire,
about 3 amperes. Half-bridge power supply based on IR2153 chip. Such constructions are popular among beginners as the first switching mode power supply. Diode is traditional. Instead of 2 half-bridge capacitors, there are only one smoothing electrolyte, C3, with 400 volts voltage. At the input are the fuse F1 and the thermistor. Thermistor is the moment of switching on unit to AC network. Its resistance is of about 3.5 ohms at room temperature. Such a thermistor can be found on the motherboard of the computer power supply. Aren't critical.
This will show I show this one is the component in the SMPS. So everyone will clear about the SMPS. What is the component in the SMPS? So I think that's all from me about the SMPS. So I think thank you.
Okay, thank you. Basically, Akram, what you are suggesting in terms of power supply is because is SMPS, right? Switch mode power supply, because basically due to its efficiency, right? Because like just what you showed just now, when 100 watt input can produce 70 watt, means that it's still very high comparing to linear power supply. I think that's why, because you are just suggesting the SMPS, right? I think that's a great idea, because most of the medical device itself in the world right now, most of them are using SMPS because it can even protect the device itself, right? So I think that's a good idea regarding power supply. So now let's us move to the third one, basically regarding the data acquisition block diagram, DAQ. So can I know anyone can basically suggest or recommend in terms of DAQ for its functionality, but you must take this as consideration, which is sensitivity, stability, and accuracy. That is the most important part. Can anyone suggest?
Yes, I think I know about this. But before that, I would like to give a simple explanation about the definition of data equation. What is data equation is, the objective of data equation, and also the part of data equation. Okay, I will share the screen. So data equation is the process of sampling signal that measure real-world physical condition, such as voltage, current, temperature, pressure, or sound, and converting the result sample into the digital numeric value that can be manipulated by a computer. So the data equation system, abbreviated by initialism DAQ, typically convert analog waveform into digital value for processing. So the component of data equation system include sensor, which is to convert physical parameter to electrical signal. Second one, the signal conditioner circuitry to convert sensor signal into a form that can be converted to digital value, and also analog to digital converter, which is to convert condition sensor signal to digital value. So for the objective of data equation system, the first one, there is 7 here. First one is must collect the necessary data at the correct speed. The second one, it must use all the data efficiently to inform the operator about the state of the system. The third one is must monitor the complete system operation to maintain online optimum and safe operation. Next one, it must be able to summarize and store data for diagnosis of operation and record purpose. So next one, it must be flexible for feature requirement and also reliable and not have a downtime for more than 0.1%. And the last one is must provide effective communication system. And then we move on to part of the data equation system. So as we can see here, there is 3 parts of the DAQ system. It is sensor, DAQ device, signal conditioning, analog digital converter, and the last one, the computer, which is the process and display the result. So for the sensor, the measurement of the physical phenomenon, such as temperature of the room, the intensity of the light source, or the force applied to an object, begin with the sensor. A sensor, also called a transducer, convert a physical phenomenon into measurable electrical signal. Depending on the type of sensor, its output can be voltage, current, resistance, or any other electrical attribute that varies over time. So some sensors may require additional component to properly produce a signal that can be accurately and safely be read by the EQ device. So the second one is the EQ device, which is contain signal condition and analog to digital converter. So signal condition, what is it? So signal condition circuitry manipulate a signal into a form that is suitable for input into an ADC. This circuit can include amplification, attenuation, filtering, and isolation. So some DAQ devices include built-in signal conditioner design for measuring specific type of sensor. For the second one is the analog to digital ADC. So this ADC, analog signal from sensor must be converted into digital before they are manipulated by digital equipment such as computer. An ADC is a chip that provides a digital representation of an analog signal at an instant in time. So in practice, analog signal continuously vary over time, and ADC take appropriate sample of the signal into predefined rate. So this sample is transferred to a computer over computer bus, where the original signal is reconstructed from the sample in software. So this data, digital data, have more advantage over analog data. Some of those are easy and fast processing, easy and fast transmission, and it has less storage space is required, and more importantly, is more accurate. So there is the computer bus. The EQ device connect to a computer through a slot or port. So the computer bus serves as the communication interface between the EQ device and computer for passing instruction and measure data. The EQ device are offered on the most common computer buses, including USB, PCI Express, and Ethernet. More recently, the AQ device have become available for 802.11 Wi-Fi for wireless communication. There are many types of buses and each offer different advantage for different type of application. Okay, I think that's all for me.
Okay, so basically, you are mentioning regarding the part of the AQ system as well as the objective of the AQ system, right? So perhaps
Yes.
because we want to basically know regarding the AQ, especially in terms of its block diagram. So basically, can you show also and maybe suggest in terms of its block diagram, or maybe block diagram, and also maybe if you have any methodology that you can show to us.
Oh yes. Thank you, Amirul, for reminding.
All
I
right.
would like to show to you guys the block diagram of the AQ. So this is the block diagram of data equation system. So digital data ecosystem contain of physical system, transducer sensor, signal conditioning, analog digital converter, and the last one computer. So I would like to share uh, the explanation from the website. This is the physical system condition. Uh, for the first block diagram, physical system. Physical system is physical condition that can be used as input of DSS or which can represent in digital form as is under temperature, pressure, light, force, displacement, level, electrical signal, and also on-off switch. Okay, alright. So we move on to the next, which is transducer sensor. Okay, for transducer sensor, it convert temperature, pressure, level, lamp position, and any other into voltage, current, frequency, pulse, and other signal. So this transducer convert the physical condition into the electrical waveform for easy signal processing. So by doing that, we can get better result of our circuit. So the third one is the signal conditioning. So for the signal conditioning, uh, circuit improve the quality of signal generated by transducer before they are converted into digital signal by the PC data equation hardware. So most common signal conditioning function are amplification, linearization, cold junction compensation, filtering, attenuation, and excitation. Also the common mode rejection. And next is analog digital AD converter. So for this analog to digital AD converter, change analog voltage or current level into digital information. The conversion is necessary to enable the computer to process or store the signal. As you can see here, the diagram, the signal input and amplified and then processed by the computer to give the output. And we move to the next, which is methodology. For the AQ methodology, it begins with the physical property to be measured. Example of the include temperature, light intensity, gas pressure, fluid flow, and force. Also, a sensor, which is type of transducer, convert a physical property into a corresponding electrical signal. The next one is the signal conditioning that may be necessary if the signal from the transducer is not suitable for the DAQ hardware being used. And then, after signal conditioning, the analog wave output is converted into digital form using A&D converter. So one digitized, the signal can be encoded to reduce and correct transformation error. So the whole process is called data equation system. Okay, that's all from me.
Okay, thank you to Hafiz for the explanation regarding the digital acquisition system. So basically, the AQ is most importantly that we want to know is that it can produce something related to high speed, especially in terms of the sensitivity, stability, and accuracy. And also maybe in terms of the AQ system also, in terms of its explanation can be also done in term of like table form, or can be like in term of like diagram form. Okay, so and then we go to the fourth clue, which is the external feature, including automation control of feedback system. Okay, means that what kind of feedback system that we want to generate and then to suggest. So can anyone give suggestion regarding this method, which is the automation control of feedback system?
So I would like to try on giving some example. Explain the feedback system basic and the characteristics of and so the components that build up the feedback system. So basically a feedback system is a system which the output signal is fed back to the input. This can ensure the error can be detected, and we can also detect the malfunction in the system. This system is widely used in modern automated systems. It consists of 5 basic components, which are in the diagram shown here. First, we have the input, and then next we have the controller and actuating devices, which integrates both these actuating devices, which will sum and minus of the input, and also the controller. And then the third component is the process, the output, and lastly the sensing elements. So all these components build up a feedback system, and we can also call a closed loop. This feedback system or closed loop is used to first use errors by automatically adjust the system input. Second, to improve the stability of the system, and lastly to increase the sensitivity of the system. So to understand more about this point, I would like to share to you some a video. So this is a closed loop system that will show you how it works. You can see the system is automatically adjust the speed of what it detects in low. We lower the system driver, and once it speed up, it will speed up also the system driver. So to implement the feedback system to this hand grip dynamometer, it is ideal to monitor the strength of the patient's hand grip. This is the basic block diagram of the information. First, we can see the patient, and then the gripper, the hand grip. And then inside, we have the sensory circuit, and then we have the data communication interface. And then we have LCD display, or we can also display in the PC for analysis. From the display, the doctor can, from the LCD display, doctor can deduce what is the patient's hand grip strength. This system combines hardware and software through a user interface. Started with the patient hand grips, then the dynamometer is now loaded, and the exact strength is recorded through a sensory circuit, as I mentioned before. And as what Hafiz mentioned before, the DAQ, which consists of AD, or we can also ADC, which is analog to digital converter. The sensor circuit measure the hand grip strength of the patient, and then will translate to digital into voltage signal information, and then the data will be displayed and we can monitor inside the rehabilitation program. That's all from me, and back to the team leader Amirul. Thank you.
Okay, thank you, Aiman, for your suggestion and recommendation regarding the feedback system. So means that what you are suggesting right now is basically the closed loop system in order to make it reduce error, right? And also to improve the stability as well as increase the sensitivity. Means that by using that system, it can produce a better like good in terms of system for that device itself, right? Okay. So the next one will be the system fault condition. So I need anyone to suggest in terms of, let's say that the system fail to supply sufficient power source to the system in order to operate. So can anyone give or provide any possible solution so that it can overcome the failure that I mentioned just now?
Okay, thank you, team leader. I would like to discuss about that problem with all of us here. So before going into the suggested system fault recommendation, I would like to share with you guys what is the meaning of the fault condition. So, so before going into the solution that I have provided, which is the lithium-ion battery, so let's discuss a bit about what causes or what is electrical faults. So any medical devices or any other electrical devices, they are often subjected to various types of faults while they are in operation. This could be due to a number of reasons uh, that causes the faults to appear in our power system. It includes power shortages like blackouts, lightning, or trees falling on electrical lines, or even apparatus failure. So for any medical devices that uses direct power supply, it is very prone to this risk of power shortages if suddenly the power went out. So to tackle these problems that I've mentioned, I would like to suggest two types of solutions. Firstly, is this the lithium ion rechargeable battery, which you can see on my screen now. This is how it looks like. So the difference between lithium ion rechargeable batteries is they are of course they are rechargeable, and the chemical reactions in a rechargeable battery are reversible, which is why we could charge and discharge the battery. As compared to ordinary batteries, the flow of ions is only one directional, and once it's finished you have to throw the batteries away. So um, that's not very suitable for our system. So I would suggest that we use rechargeable batteries. So even if the power went out, we would have the backup power, and also the backup power that we have is rechargeable. So next, about the other fault condition that I mentioned earlier. Also, apart from the disasters that could happen, such as power outages and all that, an electrical fault is also could be a deviation, which is a difference of voltage and currents from normal value or state. So to solve this, I propose that we use an electrical safety analyzer kit or device so that it could measure and also ensure that our device is performing and the readings of the voltage and the amplifier meets safety standards, so that it does not exceed the standards that have been set in the various standards that we have, such as and also an electrical safety analyzer could perform a number of different tests, such as the ground continuity test, insulation test, high voltage test, and line leakage test, as you can see here. So there are a few standards that we must meet in order to ensure that our device is safe for usage. So the most popular international standards are, just to list a few: IEC 990, IEC 335, IEC 1010. So this is all the standards that we have learned, and we must ensure that our device meets all these safety standards so that it performs well every time. So that is my 2 point solution to solve the problem of system fault condition. So what do you think, team leader? Is it acceptable, and can we use it?
Yes, of course, Syed, because I think that's a great idea in terms of battery and EST itself, because EST battery itself, it can help. Let's say that there is like lack of power supply. Basically, the battery can help to just like temporarily support before the power supply can be repaired again.
Yes.
And the most important, actually, I really appreciate that you mentioned regarding the EST itself, because as everyone know regarding medical device, right? Most of the time, EST is very important for medical device, because we want to know like its leakage current test, like patient auxiliary test, and many
Yes.
more. In order, because like medical device, right? Like for our problem itself, that we want to create something that in order to for the patient, right? Means that the device will be used by the patient, so that it's very important that we know if there is any leakage current test, because we want to treat the patient, but we don't want that our device will harm the patient, right?
Yes.
So I think that's really a great idea. I really like the idea regarding the EST test, right? I think that
Thank
is
you,
a
team
very
leader.
good idea. Okay, by right, so means that we already know the clue regarding for the treatment for the patient, which means that in terms of medical instrumentation system, for a power supply, the AQ system, external feature, especially the feedback system, as well as just mentioned by this Syed in terms of possible solution if there is any failure in order to supply the sufficient power source, right? Okay, so before we can conclude regarding all the item that we already mentioned just now, is there anyone want to add more point, or we can just conclude that? I want to know if anyone want to give more suggestion. The participant.
I would like to show to you guys the video of data acquisition.
Oh, that will be great. That will be great.
Yes, it's a graphic video that so you guys have more understanding about the data acquisition. So this is just the simple video about data acquisition. There is no explanation about this. That's the graphic videos. So the objective is data acquisition to save time, improve testing quality. So this is the complete the ecosystem, transducer, signal, and analog. So this it gives the explanation one by one of the block diagram. So as we know, transducer convert a physical parameter into measurable electrical signal. So this is the example of transducer, photoresistor sensor, microphone, and also potentiometer. The signal conditioning amplify with signal, which instrument amplify. So the filtering to remove the disturbance inside signal, which is noise. So signal conditioning also can convert the 4 incoming signal into one. So this is the Russian barrier, which is for safety purpose, prevent high voltage surge to damage PC, prevent measurement error due to the different ground level between target. So as we can see here is the autocoupler. This is the high voltage and low voltage. It have a low risk. It is the magnetic accelerator and also the capacitor accelerator. It's convert to the low voltage. So this is ADC, as I just said just now. It's purpose to convert analog voltage of current into digital information. Okay, that's all. Proceed, team leader.
That's great, Hafiz. Basically, we can know the overview in terms of graphic that you showed just now in the video, so we can understand better the process, each of the process of the ecosystem. It's great, actually. It's really great. So I also, is there any more suggestion from the others?
Okay, I just want to confirm. I just want to agree with the site before about the EST. Okay, as you know, I have an internship before at the KPJ Rawang. So the EST is very important. We do the PPM. PPM is called Plan Preventive Maintenance. So EST is the most thing when the supplier or the engineers in the KPJ, the supplier come from the outside. So in PPM also, the EST is very important doing. So I very agree about the suggestion from a side about regarding the EST. So I very interesting.
Yes, it really nice idea by mentioned by Syed earlier, like regarding EST. I think most of us, basically in terms of medical field, right, will be really agree regarding EST, because I'm sure that most of us already experienced regarding EST, and we know actually what is the importance of EST, right?
Yes.
That's really great idea. So any more comment, suggestion?
None from me. No.
No? Aiman, no? Hafiz? Akram? Okay, so if like that, so we can conclude that in terms of all the 5 clues that being mentioned by each and every one of you just now, so we can conclude by taking basically everything that you guys mentioned just now into account, we can analyze the issue, and discover the kind of medical instrumentation that we want to use. This is very important to know and make sure we understand the equipment that we want to use. That is more important. And also, most of the time, muscle injury most of the time can be treated by just like doing some simple protocol, because some of that is the technique is can really produce a great outcome basically. So we really need to understand the device that we want to use, and also we can also similarity with the digital conversion technique to basically persistently process the signal adjustment in data acquisition that being mentioned by Hafiz just now. This is I think that data acquisition is very important, as well as just now that you mentioned LabVIEW, right? LabVIEW really familiar in using the AQ system, as well as the most crucial thing in order to creating this equipment is to make sure that the equipment is very efficient. Efficient equipment means that we will create a good outcome. That's why there's just now that when you guys generate the idea just now, it's really great because we really want to produce something that is very efficient, and also high accuracy measurement. Just like mentioned by Afi just now, the needle have a good measurement, right? So that is really nice. As well as the most important is user friendly, because we want to use it for patient, right? For user, for patient. Patient is basically the user as well as the doctor. So by doing that, basically describing that our suggestion is really useful and appropriate, especially to treat the patient without having to have the patient to go to the surgical operation room. Okay, I think so that by that this conclusion, I will pass to our chairman. Dear chairman, basically that is what our discussion just now. So I will conclude the point, each of the point regarding the problem statement that you mentioned earlier in the discussion just now, Mr. Chairman.
All right. What I can conclude that very lot output that we can get from this discussion. First, I think the equipment that we use will produce a great outcome. For the second point, for the third point is will produce the efficiency, and also for the first is the accuracy. What can I conclude that all the recommendation is very good, and one more thing, all the main point that had been elaborated very, very well. All right. So thank you for the hardworking plan and put this wonderful idea to being a sharp and attentive team. And big thank you also to the audience and for lend me your ears. So before we end our sessions, I have one quote that says, "Coming together is beginning, staying together is process, and working together is success." Thank you for everyone. All right. So before we end, now for about I think a few minutes, I think we will working around with a microphone for any of you with a question. Just raise your hand and introduce yourself, and we will do our best to provide the answer. So for the audience, thank you so much. Yes, Aisha, yeah.
Okay, since I just want to ask, what are the important elements you are taking in consideration to make this system? Like the stability of a person, I mean the heart rate reading, do you take that as important element, or you just ignore it, or you just create a system based on the hand grip itself?
Okay, for the system itself, in terms of this, we doesn't ignore it, but it doesn't include in the system itself because we are producing a device basically in terms of its in terms of aggregate system, like in order to muscle injury. But this is very what we call basic things in medical field, especially in hospital itself. Before you being treated in any kind of disease or any kind, just from small problem to big problem, you will be taken your heart rate, your blood pressure. So in terms of heart rate that you being mentioned just now, it will be taken in and out before using this device. Thank you. Thank you, Aisha, for the question just now.
So, any others, audience, want to ask any questions, please?
So basically, you are saying that the heart rate reading and so on, and the important elements affect the reading of the system, isn't it? Is that
Yes.
what you mean?
Yes.
Okay, that's all for me. That is my question.
Thank you, Aisha.
Thank you for
for the
answering.
question. Really good. Your question basically can help us to like test it like procedure right before in order to produce in order to use this device. It's really good idea because heart rate system is very important in terms of medical field, right? Thank you, Aisha.
All right. I see Sharifah, right? Sharifah Norain Najah, right?
Yes,
All right. What is your question,
I want
please?
to ask. What is the effect when the power supply is failure?
Okay.
Ada tak?
So I will answer this question, Sharifah, because it's most related to my explanation before. Is when supply is failure. So basically, it have a lot of effect that can be done, can be do after if the power supply is failure. For the first one, all the record data will be lost if the power supply is failure and do not save. So we have a lot of details data that the treatment, the detail of the patient. If the power supply is failure, so you have a lot of things that be. Second one is if the power supply is failure, we need to reset. So it have we need to reset back all we have a delay. So if the equipment need to have equipment need to use it will delay the cases. So okay, if the someone have a power supply, so it's corrupted, so we need to back, and it need to have a long time. So it have caused a lot of problem when when we arrange the cases procedure for the another. So it have a lot of effect. It will have a lot of effect. So thank you, Sharifah, for the question.
Hello, can I ask a question?
Right.
Okay, can we use only dynamometer sensor on the hand grip?
Okay, Kimi, regarding your question, it relates to my explanation earlier. Can you guys hear me clearly because it's raining heavily here?
Yes.
Okay.
Yes.
Okay, thank you for your question, Kimi. So the reason in any medical device, if we want to ensure the reliability and the accuracy of the data, we need several or various ranges of data that we can collect and process and interpret it into information. So although I said earlier in my explanation that the dynamometer is used to test hand grip and it could also indicate diseases in the future, but there are also research that suggests that it could not be as accurate because it is only a very one-dimensional data that is only hand grip strength. So in order to increase that accuracy and also in a way make our system better, that is why we introduce EMG so that it could evaluate the health condition of the muscles, and also if the reading is abnormal, it could be an indicator of muscle disorder such as muscular dystrophy or even nerve disorders such as ALS. Again, to answer your question simply, yes, we could only use the dynamometer, but then to make it more accurate and make our device better, we have decided to use the EMG as well. So that's all.
Okay, thank you, Syed.
Alright. Now, is it any question? Only one person, one question only, right?
Wait, before that, actually we have one question from the meeting chat itself. The question is, what type of amplifier do you suggest to apply into the instrumentation to make sure that the device can get a data from patient accurately without any distortion? This is the question from the meeting chat.
For Muhamad Firdaus, yeah, the question how we want to suggest to apply the instrument to make sure the device can get the data patient accurately without any distortion. All right, basically your question is quite big, general. We can use so I will explain about general solution also. Basically, we use a non-inverting and also to overcome the distortion, we use a filter. So that for the answer for the question that because we can know that every devices have their own specifications. So we want to know what kind of device used so that we can know the percentage. There's a lot of calculation that we need to know. For basically for the roughly, I answer the question for just roughly. We use a non-inverting, and also to overcome that, we use a filter. All right, thank you. All right, now we go to the next question, which is Aina Shahira, right?
Aina, raise your hand.
Yeah.
All right, what's the question, please?
Why do you use rechargeable battery instead of regular batteries?
So why we use the rechargeable battery, right?
Yeah.
Okay. The answer is very simple. This is because rechargeable battery is a safe call since there does not require a frequency change. So it also for the better the environment. I think that's my answer. Is it clear, Aina?
Yeah. Thank you.
All right. Okay, we go to the next question, which is Anis Ardiana. Yeah? Go. What's your question, Anis?
What is ADC or AC, and what is the function of it? Thank you.
May I answer that questions? So basically ADC for its name itself, ADC analog to digital converter. So like its name, it's convert the analog signal such as sound or light into the digital signal. I hope that answers the questions.
Yes. Thank you.
Thank you, Anis Ardiana. Any other question?
Kabilan, raise your hand, right? Kabilan, am I right?
Yes, I am.
Okay.
So I have question.
Sure, Kabilan.
Just a simple question. How EMG signal is generated from the muscle?
I think that question relate to my explanation just now. How EMG signal is generated from the muscle, right?
Yeah.
So as we know, the muscle, when we move our hands, the muscle have the contract and release. So the muscle fiber generate electric activity whenever the muscle are active. So AMG signal are recorded by placing electrode close to the muscle group. So when the muscle is moved, when it active, the length of the muscle decrease and the muscle skin and electrode move with the respect to one another. So therefore, the signal of the muscle action potential is picked up by the electrode and then amplified. And then we can see the result at the display at the computer.
Okay, thank you for your
question.
explanation. Yes,
All
you
right.
have answered my question. Thank you.
Okay. Thank you, Kebilan, for the questions.
There is one information at the meeting chat, which is there will be no more question allowed to be asked.
Okay, alright.
Kabilan should be the last one that will be asked.
Alright. So, Amirul, is it another amendment for this meeting?
Yeah, I'm sure after being asked by the audience, we can know that the audience want to know more. And actually, I really appreciate the audience for giving your time to ask the question, because your question is actually giving us the opportunity to improve our recommendation regarding the problem statement. Right? It's really great for you guys to ask the question. It can help us to generate more idea. Okay, I think that's all from us for today. Thank you. Actually,
Thank
that's
you.
all.